Stars are some of the most fascinating objects in the universe. They are the building blocks of galaxies and have played a significant role in the evolution of the cosmos. Despite being such a common and visible phenomenon, there are many interesting facts about stars that most people are unaware of. In this video, we will explore some of these lesser-known facts about stars. Number 1. Stars are not solid objects. Stars are made up of gas and plasma, which are constantly in motion. The outer layers of stars are not fixed, solid structures, but rather fluid and dynamic. The gas and plasma in stars are mainly composed of hydrogen and helium, which are the two lightest elements in the periodic table. The high temperature and pressure within stars cause hydrogen and helium to undergo nuclear fusion, releasing energy in the form of light and heat. Number 2. The color of a star indicates its temperature. The color of a star is related to its surface temperature. Blue-white stars are hotter than yellow stars, which are hotter than red stars. This is because hotter objects emit more energy at shorter wavelengths, which corresponds to blue light. Cooler objects emit less energy at shorter wavelengths, which corresponds to red light. This is known as Wien's law, and it allows astronomers to estimate the temperature of stars based on their color. Number 3. Some stars are bigger than our solar system. Stars come in a wide range of sizes, from small red dwarfs that are only slightly larger than Jupiter, to massive stars that are hundreds of times larger than the Sun. Betelgeuse, for example, is a red giant star in the constellation Orion that is estimated to be around 1,000 times larger than the Sun. This size variation is due to the different amounts of mass that stars contain. Number 4. Stars are born in nebulae. Stars are born in dense, cold clouds of gas and dust called nebulae. These clouds can be several light-years across and contain enough material to form many stars. Gravity causes the gas and dust to come together, forming a protostar. As the protostar grows, it becomes denser and hotter until nuclear fusion begins, and a new star is born. Number 5. Stars have life cycles. Like all living things, stars have a life cycle. They are born, go through various stages of development, and eventually die. The length of a star's life depends on its mass, with more massive stars having shorter lifetimes. A star's life begins with the protostar stage, followed by the main sequence phase, where it produces energy through nuclear fusion. After the main sequence, the star enters various stages, such as the red giant phase, where it expands and cools, and eventually dies as a white dwarf, neutron star, or black hole. Number 6. Some stars die in spectacular explosions. When a massive star runs out of fuel, it can no longer produce energy through nuclear fusion. The star's core then collapses in on itself, creating a supernova explosion. Supernovae are some of the most energetic events in the universe, releasing huge amounts of energy and creating new elements that are dispersed into space. These explosions can also create neutron stars or black holes, depending on the mass of the star. Number 7. Stars can have planets. Many stars have planets orbiting around them, just like our Sun has planets in our solar system. These planets are called exoplanets and have a wide range of characteristics, from being similar to Earth to being completely inhospitable to life. The first exoplanet was discovered in 1992, and since then, thousands of exoplanets have been discovered using various methods, such as the transit method and radial velocity method. Number 8. Spin of the stars. Stars can spin incredibly fast, with some rotating at speeds of up to 600 kilometers per second. Rapid rotators are often young, massive stars that have not yet exhausted their nuclear fuel. The high rotation speeds of these stars can cause them to bulge at their equators, creating an oblate spheroid shape. The rotation of stars can have a significant impact on their behavior, influencing their magnetic field, activity, and evolution. The study of rotation rates of stars can provide insights into how they form and evolve. Stars twinkle because of Earth's atmosphere, which refracts the light passing through it. Stars can have magnetic fields, with some stars called magnetars having an extremely powerful magnetic field that can produce bursts of high-energy radiation. Parallax is a technique used by astronomers to measure the distance to nearby stars. Stars are often used as a standard candle to measure distances in the universe. Stars are fascinating objects that continue to amaze and inspire astronomers and the public alike. Number 9. Stars can have magnetic fields. Stars are made up of charged particles such as protons, electrons, and ions, which are in constant motion. This motion creates magnetic fields within the star, similar to how Earth's magnetic field is generated by the motion of molten iron in its core. These magnetic fields can have a significant impact on the star's behavior, influencing its rotation, activity, and even its shape. For example, some stars have spots on their surface that are caused by magnetic activity, similar to sunspots on the Sun. Magnetars are a type of star with an incredibly strong magnetic field, around 1,000 times stronger than the magnetic field of a typical neutron star. The intense magnetic fields of magnetars can produce bursts of high-energy radiation, including gamma rays and X-rays, which can be detected by satellites and telescopes. Number 10. Stars can be used to measure distances. Astronomers use a technique called parallax to measure the distance to nearby stars. Parallax is the apparent shift in the position of an object when viewed from two different points. In the case of stars, astronomers measure the parallax by observing the star from opposite sides of the Earth's orbit, when the star is at its closest point to us. By measuring the angle between the two observations, astronomers can calculate the distance to the star using trigonometry. The distance to a star measured using parallax is called its parallax distance, and it is typically measured in units of parsecs, pc. 1 parsec is equivalent to 3.26 light-years, so a star with a parallax distance of 1 pc is about 3.26 light-years away. Parallax is one of the most reliable methods for measuring the distance to nearby stars and is an essential tool for astronomers studying the structure and evolution of the Milky Way galaxy. The Sun is expected to become a red giant in about 5 billion years, which means it will expand and engulf the inner planets of the solar system, including Earth. During this process, the Sun's brightness will gradually increase and eventually stop shining, becoming a cold and dark white dwarf. This process will take many billions of years after the Sun becomes a red giant.